Hello! In this video I would like to explain how you can install the Vision app in the iRC and calibrate the camera. For this purpose I will be using a USB camera, the igus Delta robot and the igus robot control. We also need the zip file of the Vision app. You can download it via our wiki or RBTX. After downloading the file, you can open the iRC and connect to the robot. Then open the interface configuration and select Apps. You can now install the app on the robot via Install App. To do this, select the zip file of the Vision app and activate it. Use split screen to display the robot on the left and the Vision app on the right. You will now see the image of the camera if the USB port of your camera is 0. Otherwise, you can change the port here. Depending on the camera used, it may offer options for adjusting the focus, for example. Set the camera so that you can recognize a good image in the app. The settings on my camera are already right. Calibrate the robot to make sure it knows where the camera is pointing and what its orientation is. For this you will need the calibration sheet. To achieve a high level of accuracy, I use a measuring tip for calibration. You can also find the 3D data of the measuring tip and the calibration sheet in our wiki on RBTX. However, you do not necessarily require a measuring tip for the calibration. The calibration can now be started. To do so, I place the sheet under the robot so that all 4 dots can be reached with the robot's TCP and all 4 points can also be seen in the camera image. It's best to try it out once. My sheet is now positioned so that the robot can reach all dots and I can also see all of them in the camera image. The first dot is now being calibrated. For this, the robot's TCP is moved to dot 0 on the calibration sheet and this position is saved. Do the same for the other 3 dots. It is important that the sheet is not moved until the end of the entire calibration. Once all dots have been saved, the accuracy with which the dots were measured is calculated. This has an effect on the accuracy when gripping objects. It should be close to 1. If the accuracy is too low, you can go back and measure some or all dots again. Save the dots if the accuracy is good. The camera must then also measure the same dots to synchronize them with the coordinates of the robot. Move the robot outside the camera image so that the camera can identify the 4 dots. The region of interest must then be set. This is the area in which the camera searches for the dots. This area is marked by a black rectangle. At the bottom of the screen, click on the top left-hand corner and then on the bottom right-hand corner. If the 4 dots are in the black rectangle, click on Continue. The app now tries to find the 4 black dots on the camera image. When the camera has found a dot, it is initially outlined in red. You can see that the camera has already identified some of the dots, but not all of them. Use the image filter settings to change the contrast and brightness of the image until the 4 dots can be recognized. If this is not sufficient, Please check the lighting. If it is too bright or too low, the dots might not be recognized without problems. In my case, the settings are now correct so that the camera has identified the 4 dots. An accuracy is also specified for the dots measured by the camera, which should be close to 1. If the 4 dots identified are wrong or the numbering is incorrect, start the calibration again. To ensure that no incorrect dots are saved, I make sure the numbering of the camera matches the numbers on the calibration sheet. If the 4 points have been identified correctly, you can save the dots and end the calibration. You can reset the image filter settings and remove the calibration sheet. The camera is now fully calibrated and you can start setting the parameters so that your workpiece is identified. I will explain how to make these settings in the second video on the Vision app. You can find further material instructions on our wiki page. Thank you very much for your interest. See you next time.